So the topic for today are free body diagrams. Free body diagrams are really cool because you're able to analyze all the forces that are acting on an object. Um, the object itself may be drawn as a dot or a box, and we label all forces, all external forces on that object. So what are the forces acting on the object? So one of the first ones is applied force, and this one's very simple. It's simply the force that you're applying to an object or to another person. So for example, a person is pushing a desk across a room, so this is your applied force. Okay, and remember, with every force, there has to be something opposite of it. That's why we have in this picture, if you notice, we have applied force, but we also have a frictional force counteracting that, and we'll go into that a little bit. We also have gravity force, and we've talked about this a little bit already. Gravity will be moving downwards, and that's how the force of gravity moves. And so we always represent this as moving down. Even if you're on an incline plane, it's still moving down. And right opposite of gravity, we have the normal force, or sometimes we call this a support force. And it's exerted upon an object that is in contact with another stable object. Now, with the normal force, for example, if a book is resting upon a surface, then the surface is exerting an upward force upon the book in order to support the weight of the book. So if you remember a few lectures before, we talked about how if a book is laying normally on a table, gravity is affecting it, but there's also a normal force being applied to it. Otherwise, if only gravity is affecting it, it would fall forever, it would be in free fall. So we also have friction force, and this is exerted upon a surface as an object moves across. And so, for example, let's say you're exerting an applied force to the right. Well, there has to be a frictional force going against that, because that object is not going to be moving forever. There is some type of friction. So let's draw a free body diagram for a circus elephant that falls off a tightrope. So let's draw that for a falling elephant. So I'm going to just represent the elephant as a box here. So as it's falling, of course, we have the force of gravity pushing down on it. As soon as it hits the floor, so let's say for an instant it hits the floor, there is some type of force acting up on it. So that's the normal force. And that's it. We don't have any left or right forces. So let's say a book is at rest on a tabletop. And we've gone over this one before. Of course, gravity is facing down on it, but we also have the not applied force, but the normal force in order for it to be balanced. So this, for example, let's review that is a balanced force. That means those are equal, and so it is at rest. A girl sitting on a swing at the playground. So let me draw this. My horrible attempt at a swing, and let's say this person is on the swing. Horrible picture right now, but now we can draw our free body diagram. So of course the easy one is the force of gravity pushing down on the girl. We don't have any left or right forces acting on it, so it stays the same, but we do have the normal force. We still have a normal force acting from the seat. So free body diagrams are useful to quickly see if there's an unbalanced force on an object. So if the object is in equilibrium, the net force is 0, and so that is at rest. If they're unbalanced, that means that some acceleration is occurring. It is moving somehow. So let's calculate the magnitude and direction of this free body diagram. So we have a force of 20 newtons to the right and 60 to the left. And so because they're going opposite directions, just like vectors, we subtract them. So 60 minus 20 is 40. And it's going in the direction of the larger vector. So I would say it's going 40 newtons to the left. And so that's where this object will move. Now again, we have 50 newtons upward and 25 newtons downward. And again, they're in opposite directions, so I'm going to subtract them. So 50 minus 25 is 25 newtons. and it'll go in the direction that has the more force, which is the 50 Newton force. So it's going 25 newtons up. Okay, so this is an unbalanced force here because there's some acceleration going on upward.